called Mission to Mars. So he's talking about the idea that as astronauts and scientists are trying to figure out a way, like, could we ever actually live on Mars?
Mr.
Right?
Lagoon, is that Julie Payette?
Mr.
Sorry?
Lagoon,
Is that Julie Payette?
In the picture?
Yeah.
I'm not sure, actually.
Mr. Lagunas,
Yep.
in the old days, people actually tried to go to Mars?
In the old days?
Yeah.
No, not Mars, not that far.
But it looks like an old picture.
Yeah, but that they weren't going to Mars, though. They were maybe going to the moon or something.
And have they actually achieved to go to Mars?
Well, he's going to talk about it in the video. No person has been there, but they have sent things up there.
A drones
and little.
But what about the movie Martian?
Did they?
Well, that's a movie, though, right?
Yeah, but wasn't that connected?
If it happened, no, it's a fiction. It's just because it happened in a movie doesn't mean it's real. It's an idea. It's like what could happen.
Okay.
So yeah, like what could happen or what. That movie was good because it was pretty real. It gave a real problem that could happen. And also they talk about how long it would take to get there.
3 years.
Going to Mars, it's not like driving to the corner store, right? It's not like driving to the mall.
3
Going
years.
to Mars is like a significant part of your life.
Yeah, imagine, like, I'm 10 right now. Imagine me reaching Mars when I'm 13.
Yeah, something like that.
And then when I come back, I'm 16.
You're 16. Yeah, exactly. So that's a good way. That's a good comparison. It's like the journey would take longer than you could stay there, right? And what if you stay there for 1 year? Then it's like 3 years to get there, 1 year to live there, and then 3 more years to come back.
Oh, I will be 17 by then.
Right. And that's only if you stay for 1 year. What if your mission is to stay for 5 years? Then it's 3 years.
I'll be over my 20s.
I'm about like 20 years old.
Right. So that's, if you consider like the journey, how long the journey would be, it's quite a big.
Yeah. So I'll be 21, 11 years from now.
Right, and you wouldn't go as a 10-year-old, right? You'd have to be properly trained. Most astronauts don't actually even go to space until they're like 30 years old or more, because there's a lot of training.
Yeah.
So, something to think about. Well, Iman, if you were going to travel somewhere for 3 years, you're not just going to like stop in, take a picture and leave, right? You're probably going to stay for a while. So yeah, some people might stay. If they were going to another place, they might stay. Right? Maybe not a full year, maybe 6 months or something, but depends on what the mission is. So I think we have enough to start. And it's 10:52, so it'll take almost to lunch. And then there's going to be a little question at the end. And because this isn't live, I can pause it and replay it if you miss something, like I can pause it and just go back a little bit.
And welcome back. So today's episode of Space for All will be a mission to Mars. Now, if you go out on a clear night sky at the right time, you might notice a small orange dot in the sky. And what's amazing is we seem to be fascinated for a very long time with this little orange dot in the sky. That, of course, is the planet Mars. Now, why are we so fascinated with it? And we've spent more time exploring Mars than we have a lot of places on Earth. Why is that? Well, it probably starts a very long time ago. We had a lot of astronomers would notice the red planet. It is obviously different, and so it drew our attention. We started to wonder what it was about. In the 1800s, there was an Italian astronomer named Schiaparelli who started to, using a primitive telescope, looked into the sky and started to draw what he saw there. Now, again, the images weren't all that clear compared to what we can see today, but you can see one of his diagrams here. And he often thought that the darker areas were seas, so he called them mare, another kind of better version there. And you saw these lines that were going from the seas to other areas. He called them canale. Now, what he meant was, much like on Earth, we have seas and oceans and lakes, and coming out of those are rivers and streams, things like that. Well, that's what he meant. He used the word canale, which for some people was misinterpreted to mean canals. Canals are things that humans build to move water around. So unfortunately, that led to the idea of, does he think that there is life on Mars? And that started us off in quite the direction. There were books written about aliens from Mars. In the 1930s, they didn't have the TV back then. They had radio, and people would do radio shows talking about different things. They would act it out with their voices. And the one particular episode with Orson Welles, he on Halloween didn't tell the people that he was acting out something, and actually made it sound like a news report that there were aliens from Mars landing and attacking people, and they had sound effects and everything else. And people truly did think that we were being attacked by Mars. Well, of course, Hollywood has taken that idea of Mars and Martians and aliens and run with it. And there's lots of, especially older movies that talk about exploring Mars.
There's no knowing what tonight's pictures may show. We may learn more about Mars in the next few minutes. So that's the baby in prison.
So clear, it's unbelievable.
This is the first picture. We took it a week ago tonight. See, here are the indentations I told you about. They couldn't be plainer. And all going from north to south.
What are they?
Canals, what else? Reversing the entire planet.
And these big shadows, here and here.
Now you know how New York or Chicago would look if photographed from Mars. And look at those mountains at the pole. They must be as high as the Rockies.
How do you tell they're mountains?
There have to be. What else would throw such deep shadows? Vaulting. Look at the canals.
They're different. Now they reflect light like mirrors.
Water reflects light. Well, so does any other. Nothing there, Iris.
But I saw it.
What did you see?
It was like a huge, distorted face with 3 bulging eyes.
But there's nothing there now.
So there's a couple of examples of some older movies. I think it's funny to see that they thought there would be palm trees on Mars. What is amazing is they have the rocket landing in a way that we've only just been able to accomplish recently. But this, of course, led to the whole idea of aliens, and specifically aliens from Mars. So let's take a closer look at the planet. Like I said, it was fascinating to see it in the sky. It looks red. Even without a telescope, you can tell that it's red. And of course, its name Mars comes after the Roman god of war. And if we compare it to Earth, well, it's actually got a few similarities and a few differences. Now, here's a couple of pictures, one of Earth, one of Mars, side by side. Can you tell which is which? It's not easy.
Yes.
There's Earth on the left and Mars on the right. So one of the differences is their orbits. They are both part of those inner terrestrial planets that we have. These are solid and rocky planets, but they're in different orbits. if we look here, you can see, of course, that Earth is going around, takes us 1 year, 365 days. Mars, further out, takes quite a bit longer. So their orbits are different. Like I said, 1 year on Earth is, we round it up to 365 days. Mars is almost twice as long, 687 days, about 43 days less than 2 years. And of course, while the planets are orbiting around the sun, all the planets are also revolving on an axis. That gives us 1 day. Now, here is where one of the similarities, they're very close to what we have. We round it up to 24 hours on Earth, and Mars is just slightly over 24 hours. We call a day on Mars a sol. It makes it a lot easier to try and remember if you're talking about a Martian day as opposed to an Earth day. Now, Mars is smaller than us, so it has slightly less gravity. Everything has gravity. The bigger you are, the more gravity you have. We, of course, live on Earth, so we just call that 1 gravity because that's where we live and we compare things to that, whether it's greater or less. So Mars, being smaller, has 38% of the gravity. So if you weighed, say, 27 kilograms on Earth, you would only weigh about 10 kilograms on Mars. Now, as far as the atmosphere on Mars goes, well, it does have an atmosphere. The atmosphere is very thin compared to that of Earth. It's only about 1% that of Earth. And the atmosphere that we have here, the atmosphere that you're breathing right now, that's air. It's made up of nitrogen, oxygen, and some other gases. Well, the atmosphere on Mars is CO2. That's what we breathe out. So it's not thick enough for us to breathe, even if it was air, and it is poisonous to us. So that's not great if we want to try and live there. Now, as far as the temperature goes, well, on Earth, depends on where you are, depends on the seasons and everything else. The ranges in temperature can be 35 or more degrees Celsius, minus 20. Certainly right now in Toronto, we're hovering around 0. On average, the temperature on Earth overall, because of our atmosphere and the regulation of the heat and so on average, it's about 14 degrees. Mars is quite a bit colder. So it can go anywhere from minus 120. At the right time of year, at the right place, it can get to a balmy 10 degrees Celsius, which really isn't that warm, but warm enough for things to melt. On average, the temperature on Mars is about minus 60. So although in the images you've seen and will see, it looks like a warm desert, it's not. It's pretty cold. And Mars does not have a ring system, but it does have moons. It has 2 very, very small moons, Phobos and Deimos. Phobos is the inner and the largermost. It's only about 27 kilometers long, not very big compared to a lot of the other moons in the solar system. And Deimos, being smaller, it's only about 15 kilometers long. Now, once we had the technology to be able to go to other places and explore, Mars was one of the first places that we decided to try and go to in the 60s. So here you can see some of the first images from the Mariner spacecraft, certainly compared to what we can see today, not very clear at all, but we always start out small and kind of build on that. The first things to land on Mars, depending on how you want to interpret the word land. So in 1971, the Russians or the Soviets sent a couple of spacecraft. The first one to actually land crashed on the planet was Mars 2, they called it. But then when they sent Mars 3, it actually successfully landed on Mars and was able to send back information about the Martian surface. Now, if you think sending a spacecraft to Mars is easy, it is not. You got to remember how far away Mars is. They're in different orbits. Those things are constantly moving. Okay, the two planets are moving relative to one another. So it is very difficult. Just take a look here. There's a short list. Now, it is the earlier times, the 60s and the 70s, but you can see how many actually failed. So there was a number of spacecraft that we tried to send there, both the United States and Russia, that did not make it. And if you think, oh, that was the early times, they've gotten much better. They have, but there's still some issues. A classic problem is this. Here's the Mars Climate Orbiter. Now, this was a $125 million spacecraft that was going to go into orbit around the planet Mars. Now, it was a while ago, 1999, but still, they should have been able to do better than they did. So follow me on this. Here's what happened. NASA, the North American Space Agency that sends these things into space, they decided to build a rocket and a satellite to go to Mars. And they hire an American company called Lockheed Martin, who has built a lot of space equipment before. So Lockheed Martin uses the imperial or the English system. The Americans are one of the few countries that still does that. That means that they measure things in inches, feet, miles, and very importantly for this situation, pounds of force. Remember, they're firing thrusters to get them to Mars, which is millions of kilometers away. So that's the important one. So NASA hires Martin Lockheed. They build the spacecraft. NASA then launches it and hands over the control, the navigation to try and get to Mars to one of their divisions called the Jet Propulsion Laboratory in California. Now, trying to get from Earth to Mars is not easy. Like I said, the two planets are orbiting around the sun at different orbits, so they're constantly moving, and it's kind of like trying to throw a football the length of several football fields or even longer and hit someone who's running to try and catch it. Very, very complicated. We're looking at millions of kilometers here. Now, Jet Propulsion Laboratory, along with pretty much every other space agency and space organization, they use the metric system. It's just a better system to use, and that's kind of universally accepted as the way you measure things, at least for space exploration. You guys have learned that. That's millimeters, centimeters, kilometers, and newtons of force. Okay? So here's what happens. The spacecraft is on its way to Mars, and it's continually sending information back to JPL, telling it where it is. Like I said, you're trying to send this spacecraft millions of kilometers to get to where Mars will be in about 7 or 8 months. So you're constantly making small changes. So they need constant information. And the spacecraft is sending that to JPL. JPL assumes the information they're getting is in what's called Newton seconds. Here's the problem. The spacecraft was operating and sending information in the English or imperial system, meaning pound seconds. So when they were firing the rockets, the information they were getting was wrong, which led to them having a wrong trajectory when they got to the planet Mars. So instead of going into a very high orbit and circling around the planet, which is what you wanted it to do, and look back on the planet and gather that climate information, it had to be about 226 kilometers above the planet. Well, it was off because they had miscalculated. And instead of going there, it was only 57 kilometers above the surface. The end result is that it entered the atmosphere of Mars, burned up, and crashed on the surface. So, for all of you students out there that are watching and you're upset when your teacher takes off a mark or half a mark because you got the right answer, but you didn't write down whether it was millimeters or centimeters, you didn't put down the unit of measure, just be thankful you didn't lose a $125 million satellite because they used the wrong units of measure. We're also thinking that probably some of these people lost their jobs. And you think, well, that was all in the past. That's a long time ago. Well, the Schiaparelli spacecraft sent out by the European Space Agency in 2016, not that long ago, it was doing great. Went all the
Sorry, it's just going really fast.
Okay, so there's a lot of information. We don't have to know every single detail there, but basically what happened is the company that made the rocket was using units like inches and feet, and the other one was using centimeters and kilometers. So
Yeah, but they accidentally can I explain it?
yeah, sure.
They made them. They actually tried to make them trajectory correct, but it was confusing. So basically, they had the trajectory it's like this. I'll show you on camera.
Well,
So
imagine
it's like this. It's like this. This is Mars, and then this is the rocket. It's like this, and then it's going that way.
that's right. So basically, it's like if you're answering a math question and you use centimeters instead of millimeters, you're going to be wrong because those are very different units. Okay, and when we're talking about distances like as great as from Earth to Mars, if you're a little bit wrong, it's going to make a big difference. So that's what happened. They used the wrong units. They didn't talk to each other about which units to use. So one group was using feet and miles, and the other group was using kilometers, and that completely
Wow.
Yeah. So
Totally getting this.
yeah,
We got some
We're just gonna
less
create a
info
diff-
right now. We got less info.
yeah. So that
Wait, is that are you gonna?
that's not the
wait,
type of thing I would put on
never.
a major ticket, but just it's an interesting story just to say because
Wow,
they didn't
there's
talk to
30
each other,
minutes left of this already.
because they didn't talk to each other, they got the wrong information.
What is this?
the way to
This is
Mars.
gonna bring us to lunch.
Sorry?
Oh, which,
This is gonna bring us to lunch.
okay.
Yeah, that's the idea.
Not even-
Mr. Dragones,
Yep.
so you know how you told us to do the artwork thing?
Yep.
Yeah, so I'm trying to do it, and
Send it.
I'm trying to send it.
Yep.
And I don't know how to do that because it's not letting me.
Is there a camera on your computer? Can you take a picture with your
Yeah, I took a picture, but
Okay. So then on Classroom, where if you go to the assignment, there should be a thing to let you add a file or something like that. I don't remember what it says exactly, but it should say submit and add a file, and that should then they would ask you to pick what file you want to put, and that's when you pick the picture that you took.
Okay.
You can also email it to me if that's easier. Just email it directly to me, and I'll accept it that way.
Okay, thank you.
Okay, no problem.
It was within 1 minute of landing, and they lost contact. They went looking for it with whatever spacecraft were in orbit, and, well, as they suspected, something went wrong, and it crashed. There's an actual picture from orbit of the Schiaparelli spacecraft in pieces, not how they wanted it to land on Mars. But in the mid-1970s, NASA, again spurred on by the idea of is there life on Mars, decided to send 2 spacecraft to Mars landers. They weren't going to move around. These are the Viking 1 and 2 spacecraft. Here's the actual images from their landing craft. Take a look at the rocks, by the way. We'll talk a little bit about that. You can see how pointy and sharp they are. This will come into play a bit later on. But again, here are just some of those first images we had of the Martian surface. And what they did was, using robotics, they were gathering up a sample of soil and putting it into a little laboratory on the spacecraft and trying to find out, was there evidence of life? Now, the answer at this point was no. But keep in mind, they only were getting samples from just really the surface in 2 spots. If you thought about this, if you knew nothing about Earth and you sent a spacecraft here and they landed, say you had 3 of them, one landed in the Arctic, one in the desert, and one in the Amazon, you would get very different results. So it is possible to have them land somewhere and get a result that is different than somewhere else. Just a few more of those shots. So that was a great beginning to try and look for evidence of life. Now, one of the things that happened I believe it was in the 80s, there was an announcement by NASA, a big announcement, that they had found evidence that there had been life on Mars. Well, this came from a rock that they believed had been ejected off of Mars that eventually went out into space and was trapped by Earth's gravity, pulled in millions of years ago, and was then trapped in the Arctic. Finally, NASA somehow found it. They dug it up. They spent a long time analyzing it. The black and white images you see there were what they said in their announcement were evidence of very microbial life in the rocks. Now, at that point, they then allowed other scientists from around the world to study it. And what sort of came out was that, well, you guys made a couple of really big jumps in your thought process, and that the idea that this is totally evidence of life, well, it could be, but it could also be some other things. So they kind of backtracked on this. But just to show you how some of these things get into modern culture, Dan Brown, a very famous author, wrote a book about it called Deception Point, all around the idea of finding this piece of rock from Mars in the Arctic. So once we knew that we could get to Mars and explore, well, we decided we need to move around. We need to be able to physically go around the planet to look for whatever it is we're going to find, hopefully life. So they always start off small because they don't know how this is going to work. They have some ideas, but they need to practice. So in the mid to late 90s, they launched a small spacecraft called Pathfinder to Mars. Now, how do you land on Mars? Well, that's complicated. Let's see.
Signal secure. Pad B. That's liftoff of the Delta rocket. Program is in.
So, of course, you're going to launch in a rocket, and then you're going to get rid of your big booster. You don't need it. Fire another rocket. You don't have to fire your rockets all the time. These are all animations. They, just like throwing a football, remember I said it's like throwing a football really far, they spin the spacecraft so that it goes straight. Again, they don't have to fire the rockets the entire time. Once they get going to whatever speed they want, it keeps going that fast. It takes about 7 or 8 months to get to Mars. Mars has an atmosphere, but it's very thin, as I said. So you still have the issue of getting heat from friction when you enter the atmosphere. So they do have a heat shield on the bottom. If you rub your hands together, you'll feel heat because of friction. This is a lot of heat. This slows down the spacecraft somewhat, maybe 1,000 kilometers per hour. So they use a parachute. And then what happens is they get rid of the heat shield. They don't want the added weight of that heat shield anymore. It's through the atmosphere, so they get rid of it. And then they lowered the entire spacecraft. And they have to have a way to have it land. So they come up with an ingenious way. They covered it all in airbags. So there it is, surrounded by the airbags. And then just before, as you got close to the ground, just before it was too close, they fired the rockets, which slows it down a little bit more, and then they dropped the spacecraft. It is inside these bubbles. Remember those rocks? I was going to stop it for a sec. Remember those rocks we saw from the Viking missions? How many there were and how sharp they were? Think about this. These airbags have to be pretty tough. Not to mention that first bounce, I think, went up about 1/4 to 1/2 kilometer. So it was quite a big bounce. So that had to be a pretty substantial spacecraft and robot to survive all of this. So So they used a couple of different techniques, including the bounce. Of course, people made fun of that. And inside was the two different kind of spacecraft who had the base station, named after Carl Sagan, who we saw in the picture with the Viking lander. He was instrumental in the Viking missions. He had passed, and they named this after him. And then on board, there was a small little Sojourner robot. There's a great shot of it from orbit. You can see the white things are the airbags that they had. They deflated. And then you see these two ramps, the gold ramps on either side. Some of the technology for that was built here in Canada. Another shot of that. And it was a good thing that we had two of them. When you're doing a mission like this, you need to have a backup if it's a critical thing. Because if you look at that upper picture, you see the two ramps. Well, the one on the left is not touching the ground. The one on the right did. The one on the left, the airbag, just didn't deflate properly. And so if the rover had to go down that ramp, if that was the only option, it probably would have fallen off the end and never worked. But luckily, it had the other one, and it then drove around on the planet. Here you can see an image from the base station. Now, to give you an idea of how big this rover was, not that big, 10 to 16 kilograms. You can see the people working on it with their clean suits on, probably about the size of a large wagon. Now, remember I said that one day on Mars is called the Sol. So you'll notice here, you see Sol 32, 29, 25. So each of those little marks is how far it went in one Martian day. And it didn't go very far because they were just testing it out. It had to send signals back and forth to the base station. Now, it was only supposed to last for 1 month, but it actually lasted for 3 months. Now, Mars, as we've said, is very cold, so it's got to be kept warm by its battery and keeping all the components warm. It gets solar power from the sun, but eventually it ran out or got too cold, ran out of power. And the last picture taken by that rover, oh, there it is. I'm kidding. Well, but it's a real picture taken without Marvin added in. But the whole point is that our desire to answer that question of, is there life either on Mars or somewhere else, that was what was driving this. So they then decided, well, we want to start to send more things to Mars. So one of the things that they sent was a spacecraft to go and orbit and find places to land and places to go on Mars. So the Mars Reconnaissance Orbiter. And one of the things that the spacecraft was going to do, remember those early spacecraft that went in the 60s and the 70s, they had taken images of the surface. Of course, back then the technology was not as good. And one of the things that had happened was they had gotten this image from one of those earlier missions. It's known as the face on Mars. And certainly it does look like a face on Mars, which the whole idea of, are there aliens? This just took off with this as well, that this, the only explanation was some people, aliens, whatever, had carved this on the surface. So one of the things NASA wanted to do once they had this newer technology with higher resolution images was, let's see what that looks like again. Because if it's been carved by aliens, well, that's pretty significant. So there it is. There's exactly the same spot because they know exactly where that picture was taken. And you can see that it is not a carved face. It's just a mound or mountain on Mars. And there's the two by comparison. So because of the low resolution, the angle of the sun and so on, we imagined it to look like a face. So once we had that technology and we knew, hey, we can drive a robot on Mars, let's send more robots there. This one actually went a little bit before the Reconnaissance Orbiter. And if you're going to send one, well, it doesn't cost that much more to send two. So they actually sent two identical rovers, Spirit and Opportunity, to go and drive around on and explore the Martian surface. So these are now about the size of maybe a round kitchen table. Of course, they're using Similar technology, the little Sojourner rover had 3 wheels on each side and solar arrays for power. This one has we call it a mast. That's the white pit sticking up. And on top of that are its cameras. The lenses of these were built by Canadians, and it's about 5 feet tall. So as this rover drives around on the planet, sending back video and other images, well, it's as if someone was walking around on Mars who's 5 feet tall, sending back pictures to Earth. So just to see the size difference, there's the difference in size between the Sojourner and Spirit and Opportunity. They use the same technique with the airbags to land. It worked pretty well. Why not do it again? You can see the indentation and where the lander is, the heat shield, the parachute. And because we had the chance to send 2 of them, we could send them in 2 very different areas. So they selected more of a mountainous region, the Meridian Planum, and the Gusev crater, which they thought at one point may have had a lot of water in it. So one of the questions, of course, is there or was there life on Mars? Looking where the water was would be a great place to start. So they did look there. More images from one of those rovers on the planet. You can see how rough it is. And so driving around is very, very slow and complicated. Here we have a great shot by Reconnaissance Orbiter. It's actually in 3D. It might look blurry to you, but it's not. And you can clearly see the tracks in the sand as it comes up to Cape Verde. And you can even see the shadow from that mast. Now, one of the reasons why they move so slowly is this. First of all, if they see a rock or they see a hole, well, you don't want to fall into it or smash into it or get stuck on something. And the information that they're getting is delayed. So here's how it works. The spacecraft, the rover, is on the surface. It's driving around. If it sees something, they plan out its course and it keeps going. And there's some autonomy, meaning it can, if it senses something in front of it, it'll stop and say, hey, send a signal back to Earth to say, I think we're going to crash into something, or I've stopped. So that signal has to go up to a spacecraft that is in orbit around Mars. Can't always send it there, so sometimes it has to wait. And then once all the information, the pictures, the data is sent to that spacecraft, they then have to send the signal all the way back to us. Remember the orbits of the planets. Well, sometimes that can take 15 minutes or more for that signal to go one way. So once we get it on Earth, we analyze it, send the signal back, so everything goes in reverse, and you can see why it can take a long time to move around. Here is where Spirit landed in the distance, and you can see it says Sol 65. It went 328 meters, not very far. And of course, it didn't go in a straight line because it's trying to avoid rocks or go to rocks that it wants to examine. So moving around on Mars can happen. It's just kind of a slow process. Now, Spirit lasted for 7 years. I think it was supposed to last 90 days, 3 months. And it lasted 7 years, so quite a bit longer than it was planned. And it drove 7 kilometers just over. And then one winter, they put them to sleep in the winter. They find a spot. And when they woke it up, it had sunk into the sand and they were unable to get it unstuck. And eventually the batteries wore out trying to get out of the sand. Now, Opportunity lasted a lot longer. Twice as long, 15 years. And it only just a little while ago stopped transmitting. They tried to connect to it for a while, but it went 45 kilometers. Again, much longer and further than they had ever thought it would. Now, the whole idea of, well, we're looking for life. We want to find life. We know that we should find if there is water there. So some of these spacecraft in orbit have gotten pictures. So we knew that at one point, we can see these dried up lake beds, these crevasses that were probably made by flowing liquid water.
So you can see those pictures there, those 2 that he's showing. That's exactly what it would look like if, like if you took all the water out of a river or out of a lake, that's kind of what it would look like. So there's
Basically, it's like a dried up lake.
yeah. So the belief is that there may not be any water now anymore.
Maybe later.
Yeah,
there
Mr.
might-
Gunn, since
maybe there used to be.
I saw and it said that half of the water on Mars is ice now.
Right. A lot of it would be frozen. But if there is, even if it's frozen, that's still a good sign because humans can build stuff to unfreeze water. But it's just the idea you want to know if it's there or not, if it's possible. Because if there can be water, that means there could be other living creatures. That means there could be a place for humans to live there. But as he said, it's colder, right? It's a lot colder than it is here. So humans would also have to build things to help, make life there a little more comfortable. Okay.
So we knew there used to be a lot of water or something flowing on the Martian surface. So again, we send more spacecraft there. This time they have the technology to find water, and they have found a fair bit of it. Anything you see is blue is water, but remember, Mars on average is minus 60. So most of the time the water is frozen. A lot of it is under the surface, or if it's frozen on the top of the surface there. Now, one of the reasons that they know that they found that there had been more water and that it had been flowing, so Mars may have been warmer at one point, is they found this. They call it a blueberry, and geologists see this and they see the same thing on Earth, and so they recognize that these are created by flowing water over a long time. So that, of course, gave us the idea that, okay, now let's keep going. Maybe now with our next spacecraft, we want to be able to drill down into the Martian surface. So in 2012, we sent an even bigger robot called Curiosity to visit Mars.
8 months ago, the final stage of the Mars Science Laboratory's launch vehicle pushed the craft to 13,000 miles per hour, ready for its journey to Mars.
So very similar to the other ones. It took a while to get there, a little bit longer. The problem now is this spacecraft is really big by comparison. So we had to come up with a whole new way to land. So you still have the atmosphere to contend with. You have a heat shield. So this does slow the spacecraft down to, like I said, about 1,000 kilometers per hour. And then what they did was they had the largest parachute ever deployed, at least on another planet. And that helps slow the spacecraft down as well. But of course, we only have 1% the atmosphere. So even with a really, really big parachute, it doesn't slow down quite enough. So here is the parachute. We're going to get rid of the heat shield. Again, it's just added weight. And here's the really cool part. They are going to use some robots, and they're going to detach and have another little flying spacecraft, almost like a drone, that's going to fly and get closer to the surface. Now, they can't land because those jets are going to kick up dirt and rocks and could easily damage the spacecraft. So they created what they call a sky crane, and it's going to lower this spacecraft all the way to the surface. And as soon as it touches down, it senses that it's touched down, it detaches and flies off, crashes somewhere else. That's pretty cool technology. So Curiosity is up there right now. It's been up there for 8 years and traveled just under 23 kilometers. So to show you our increase in robotics, we've gone from a very small one to Curiosity, which is about the size of a small car. And there's a selfie taken on the planet, and more evidence that there used to be a lot of water flowing on the surface.
It looks like a snowball. Why does it look like a snowball?
It's just the way the rocks, like they're smooth rocks, and the pictures sometimes are in black and white. So it comes out looking that way. It may not actually be that way, but it's just the way it looks on the camera. But I wanted to stop and consider like how clear these pictures have gotten from before. Like when everything was just kind of gray, black and white, and kind of foggy. And now you look at these pictures and it's like, it feels like you're really there, like a Google Maps kind of thing, like you're on the surface of Mars. And like you said, like you wouldn't even tell. Like if I told you this was just a picture of Earth, you probably believe me because it just looks like a desert with a blue sky. But it's actually this is on Mars, right? So
Well, Mr. Pagonis, but it's actually Mars. Yeah,
exactly,
it's kind of
yeah,
weird. Oh, we only have 11 minutes.
I know. Don't worry.
And
Mr. Gomez,
Yep.
it sort of looked like actual snow we saw.
Yeah. Yeah, it looks. I mean, so they're noticing a lot of similar things, right? Mars has some similar features to Earth. But of course, it also has some big differences, like how cold it is. And I don't think they've found, like Earth, we're lucky on Earth that there are things like trees and other things that we have used as humans to like build stuff. There don't appear to be any on Mars that they've found yet. So,
can't they just dig up the sand there?
well, you have to consider how cold it is too, right? So trees like warmer weather, right? If it's too cold, the tree won't grow very much. So they'd have to do some building. They'd have to build like big bubbles that you could grow stuff inside because they'd have to have it warm enough, like to have it as warm as Earth, basically, like 15 degrees, 20 degrees. That's how warm you would want it in order to grow plants and fruits.
And the hardest to get there is around 10 degrees.
Sorry?
The hottest it gets around there is usually 10 degrees.
Yeah, the hottest is 10 degrees, whereas for us, the hottest on Earth is like 50 degrees. So it's probably a bit cold, unless you could get humans to actually build something. But then the question is, how do you get there first, right? So all they've been able to do so far is send these robots,
Rovers.
right? The rovers.
Yeah, that means no one has ever gone on Mars.
No human has been there yet, no.
So that answers my question.
One of the issues you got to deal with is Mars, although it looks like a warm desert, is covered in dirt and sand. It is cold. There's rocks everywhere. And all of that dirt gets into your equipment, covers up your solar panels, damages even your metal wheels. So you've got to have a really, really strong robot or spacecraft to drive around and survive. Look how the wheels are all damaged, and all they've been doing is driving around on the planet. So Mars has got some of the most amazing features in the solar system. Here's a picture of Mars there. One of them is the largest mountain in our solar system. This is called Olympus Mons, and it is 3 times taller than Mount Everest. And being a triangle shaped, it's a mountain. At its base, it's 500 kilometers. To give you an idea of how big that is, well, if you were to put that in the country of France, it would take up most of that country. Not quite as tall, but certainly a massive mountain. Dead volcano is Tharsis. There's a range of these, three or so of them are kind of all clumped together, quite large. And then there's a huge canyon on Mars as well. This is called Valles Marineris. So to give an idea, it is about 4,000 kilometers long. If you've ever been to the Grand Canyon, well, it certainly is impressive. I've been there. It seems big. It's only 800 kilometers long. And of course, Valles Marineris is many times, 2 to 7 times deeper. So again, to give you an idea, how long is 4,000 kilometers? Well, if we were to take that and put it here on Earth, it would stretch across Canada or the United States. Now, like a lot of these terrestrial rocky planets, they've had impacts from rocks flying through space. Mars has gravity, as we've seen. Things get pulled in, and you have these huge basins or craters. One of them, the Helena Planeta, is 2,000 kilometers in diameter. Again, if you go to Arizona, you can see one of the more famous craters here on Earth. That's Barringer Crater or Meteor Crater. Looks huge to us, but by comparison, it's very small. There are other craters on Earth. We have a few. One in Sudbury. I know there's one Montreal, in the Quebec area, but we don't see them very easily because, unlike the one in Barringer Crater, which is in the desert, they get covered in with vegetation, trees, and water. So we don't see a lot of them, although that still happens to us here on Earth. So one of the questions students often ask is, so why haven't we sent humans to Mars yet? That's a great question. Well, let's keep in mind, whether you're looking up from Earth or, in the case of the bottom picture, a robot on Mars looking back at Earth, these planets are really far apart. At their absolute closest, which doesn't happen very often, it's 54 million kilometers away, and it can be as far away as 400 million kilometers. And keep in mind that the planets in orbit are constantly moving. Now, this has been drawn as a circle. They're more oval shaped, okay? But when you want to get there, you can only do it about every 2 years. That's when the planets are in the right alignment, and you're not going to where Mars is, much again like throwing a football to someone who's running. You're going to throw and hopefully get everything timed just right so that the football, you give just enough force, it gets to where that person is who's going to catch it at the same time as it comes down. So when you're launching to Mars, you've got to time it just right. And that happens, like I said, about every 2 years. So that takes about 7 or 8 months to get there. And then, of course, if you decide you want to come back, you've got a long journey to come back. If you decide to stay, well, you got to stay on there for 2 years until the alignment is right, and then you're going to come back. And think about it. Think about all the important things that you need. These are only 3 of them that you need to survive. And all of these things you have to have. Some of them are there, but certainly you're going to have to bring enough air and food with you. Water you need, but luckily, as we've said, there's a fair bit of water there. Most of it's frozen. This is a great shot showing Mars has seasons, and at the right season, water does actually flow. But you're going to have to gather that frozen water and clean it. So any piece of equipment that you need that is critical, you will have to have multiple versions of. As they showed in the movie The Martian, one of the great things that the author did was he showed how you have to have everything waiting for you, because you can't rely on something being sent from Earth because, well, it's really far away, hundreds of millions of kilometers away. And, well, if you have a problem,
you're also going to want to be able to pick yourself up, because if you fall down on Mars, there's really nobody around to help you. And that little Sojourner robot that we sent out to kind of scout out the surface is not big enough to help come along and give you a little lift. You don't want to have to call back to Earth and say, I've fallen and I can't get up. And, oh, by the way, I'm on Mars. As in Mercury, Venus, Earth, Mars. Listen, if you get to Jupiter, you've gone too far, okay?
problem, and you have to wait 15 minutes for them to hear that, another 15 minutes to hear it back. That's a long time in an emergency. So for now, the missions are going to be robotic. And in fact, we launched the latest, well, Canadians are part of the team usually in some fashion, but NASA launched a mission to Mars, another robot, looks very similar to Curiosity in July. That is called Perseverance, and it is going to hopefully, knock on wood, land on Mars and then start exploring. It's going to gather samples that will be left in containers all around the planet. That's one of the ways the Canadians are involved. We're involved in some of those experiments, and then eventually a future mission will come along and grab those samples and hopefully return them to Earth. One of the things, much like the Sojourner robot, where they're trying it out, is they're going to do a test of a very small little drone or helicopter, which is actually comes down on the bottom side of this rover, and they're going to see if they can figure out how to do that remotely. And of course, if it works, they'll probably end up building a bigger and better one for the future. So keep your eyes for the date of February 18th. This is, you won't, there's no cameras here. This is all animation, but this is hopefully what's going to happen on February 18th. So we'll keep an eye on that. Will we ever find life on Mars? Who knows? It won't look like this, but with more and more robots going there, drilling down, looking for it, who knows? Maybe one day we'll find it. And we're looking at going back to the moon and then exploring there, building a space station around the moon, and then maybe eventually going on to Mars. And with the timelines and everything, who knows? One of you listening today, maybe one of the people that get the opportunity to go to or land on Mars, because we're looking 20, 30 years down the road at least. So hopefully you've enjoyed our conversation, our mission to Mars, finding out a little bit about the red planet. If you have comments or suggestions for...
Okay, so the form is in the chat. It's just all little details of what he talked about today.
Another one.
Yeah, so just questions from the video. So things like details about how long it takes